Out in space, in orbit around planet Earth, lies a space station where the best and the brightest come to learn. Here at Space Academy GX-1. Welcome! We've been expecting you. All crew members, please sign in. Nice to see you again, Ensign. Click any module to continue your work.
Glad to have you back. There's always more data to analyze here.
Our game show team needs a silly sentence to help them remember the order of the planets. Please choose which of your crew members has analyzed the data correctly.
I use this sentence. Many very elderly monsters just sold Ned purple umbrellas.
This sentence helps me. My very educated mother just served us 9 pizzas.
I remember this way. Many mean pink elephants just stampeded very near us.
I memorized, my very educated mother suddenly jumped up near penguins.
That doesn't seem to fit the data. Please try again. Please look more closely here. This information may help lead you to the right conclusion. Please look more closely.
You are really thinking like a scientist now.
Starship Meteor has just radioed us for data about planetary size. Which of your crew members has interpreted the data correctly?
Some planets are almost as big as the sun.
I like the way you think.
Please choose 3 safety devices that will help you complete a mission to Pluto. When a rocket needs to travel through the asteroid belt to get to an outer planet, be sure to attach an asteroid avoider. The mission has been aborted. The mission has been aborted for safety reasons. One of the The mission has been aborted for safety reasons. One of your safety devices is not needed. The mission has been aborted for safety reasons. Please change one of your safety devices. This information will help lead you to the right answer. Starship Q7 needs us to compare the sizes of the planets. Can you select which of your crew members has the correct theory? I believe the data Please look.
You're an example for all of us.
Our news team at KSUN needs some data about the size of the planets. Please choose which of your crew members has analyzed the data correctly. You can click the planets in the data display to see more information. You might want to try this.
You should be very proud of that work.
Please choose 3 safety devices so your rocket can safely complete its journey to Jupiter. A rocket can't land on a gas planet such as Jupiter because there is no solid ground. We have just received a request for information from one of our space stations about planetary size. Which of your crew members has interpreted the data correctly? That doesn't... Please look.
Nice job! I couldn't have done it better myself.
Captain Duo has called to request information about planet similarities. Can you select which of your crew members has the correct theory?
Neptune and Pluto are called the twin planets because
Try.
From now on, I'm taking pointers from you.
Please choose 3 safety devices so that a rocket can successfully travel to Neptune. The mission has been The mission has been aborted for safety reasons. One of your safety devices is not needed. Please replace it with one essential to your mission. Try The mission The crew aboard our lunar rover has a need for data about planetary satellites. Please choose which of your crew members has analyzed the data correctly. Luna. You.
Nice brain work! You solve this stuff like a pro!
Please choose 2 safety devices that will help you complete a mission to Earth's moon. Earth's moon isn't the only moon in our solar system, so astronomers use a special name for it, Luna. The mission The mission has been aborted for safety reasons. Please change one of your safety devices. This information will help lead you to the right answer. The mission has Our lunar base station needs information regarding moons of the solar system. Which of your crew members has interpreted the data correctly? Phobos.
All planets have at
Please look more closely.
You know, you have excellent problem-solving abilities.
We have a message from the command center. They need data on moons. Can you select which of your crew members has the correct theory? this information.
Right on the mark. Keep it up and you'll soon be running the place.
Please
Welcome back. The Earth Sun Moon Simulator is ready and waiting. This camera view is on the ground near New York City, facing west.
It's sunrise on April 6, 2010. Run time forward so that it's sunset on the same day.
Fine work! You're ready to launch a great space career.
The yellow dot marks Nairobi, Kenya in Africa.
It's 1 p.m. on December 17, 3004 in Nairobi, Kenya. Run time forward so that Earth turns and it's 1 p.m. the next day. You have still stumped? To you.
Perfectly logical. Well done.
It's 6 months later, so Earth has moved halfway around the sun.
It's sunrise in Nairobi, Kenya on June 17, 3005. Run time forward so that Earth spins on its axis for 24 hours and it's sunrise in Nairobi the next day.
Good answer. Great thinking.
This camera view is on the ground near Nairobi, Kenya, facing east.
It's sunrise on June 18, 3005. Run time forward for 24 hours, so it's sunrise in Nairobi the next day.
I like the way you think.
Every day in Nairobi, the sun rises in the east and sets in the west.
The blue dot marks New Delhi, a city in India.
When it's evening in New Delhi, it's morning in New York City, on the other side of Earth. Please run time forward 2 full days so that it is nighttime in New Delhi on January 10, 2007.
Nice one. I'm glad you're on the team.
Now here's a view from above the earth.
It's evening in New Delhi, so it's morning in New York City. Run time forward so that it's sunset in New Delhi on December 14, 2012, and sunrise in New York City.
Wow, you rock! Great galaxies! Something's wrong with the simulator. I hope you can fix it.
Earth is spinning too fast. Please fix the simulation so that Earth makes the correct number of rotations each year.
Use these buttons to change the number of spins that Earth makes each year, so the simulator is correct.
Try
That was truly marvelous thinking. There seems to be a malfunction in the simulator.
Earth is spinning at the wrong speed again. Please fix the simulation so that Earth spins the correct number of times each year.
Right on the mark! Keep it up and you'll soon be running the place.
Earth spins on its axis about 365 times each year. 365 and 1/4 to be precise.
The simulator has gone haywire again.
The sun is rising in the west. but it should rise in the east every 24 hours. Can you fix this?
The sun appears to rise in the east and set in the west because Earth rotates counterclockwise, if you're looking from above. A hemisphere is one half of the Earth. The half that's closest to the North Pole is the Northern Hemisphere. The half that is closest to the South Pole is the Southern Hemisphere.
It's June. The northern hemisphere is tilted toward the sun, and the southern hemisphere is tilted away from it. Move time forward until the northern hemisphere is tilted away from the sun in 2080.
Your problem solving is simply stellar.
Around December, the northern hemisphere is tilted away from the sun and the southern hemisphere is tilted toward the sun.
The Earth is tilted on its axis at an angle. Summer on Earth happens when one of the hemispheres of Earth is tilted towards the sun's direct rays. Winter comes when that hemisphere is tilted away from the sun.
Please run time forward so that it is summer in the northern hemisphere sometime during 1776.
Yes! You're flying at my speed now!
Around June, when the North Pole tilts toward the sun, it is summer in the northern hemisphere and winter in the southern hemisphere. Now here's a view from above the Earth.
Run time forward so that it is June 21st, 2011, the first day of summer in the northern hemisphere.
You are becoming quite the expert at this. In the southern hemisphere, June 21st is the first day of winter.
It's March in 2125. Please run time forward to the next summer in the southern hemisphere.
I can see you've got the right stuff.
Around December, when the North Pole tilts away from the sun, it is summer in the southern hemisphere and winter in the northern hemisphere.
It's spring in the northern hemisphere and fall in the southern hemisphere. Run time forward so that it is fall in the northern hemisphere and spring in the southern hemisphere sometime during 2025.
You are a natural scientist.
For 3 months, starting in March, it is spring in the northern hemisphere and fall in the southern hemisphere. For 3 months starting in September, it is fall in the northern hemisphere and spring in the southern hemisphere.
Something's wrong with the simulation. Earth's axis is not tilted. Please fix the simulation so that Earth's tilt is correct.
Use these buttons to change the tilt of Earth's axis.
Great! You're thinking like a scientist already. Earth's axis is tilted about 23 degrees. Earth holds this tilted position as it orbits around the sun.
There seems to be a malfunction in the simulator.
Error! It's warm in the northern hemisphere in December. Please fix the simulator so that Earth's tilt is correct and it is cold in December.
That's precisely the kind of thinking that makes you so wonderful to have around.
In June, the North Pole is tilted toward the sun. As Earth spins on its axis each day, the region above the Arctic Circle stays fully lit by the sun. People who live near this region do not see the sun set for days or months at a time. This long period of sunlight is often called a polar day.
Please run time forward to one of the polar days in 1999, when the sun never sets near the North Pole.
A hemisphere is one half of the Earth. The half that's closest to the North Pole is the northern.
It's June.
Welcome back! The Gravity Pilot Trainer awaits you!
Now you will need to set the angle of the rocket. The thrust has already been set for you.
Set the angle so the rocket will hit the target. Try another angle. Try another. Set the angle so the rocket will hit the target. Try another angle.
Wow! You rock!
Set the angle so the rocket will hit the target.
You've got a great head on your shoulders.
Set the angle so the rocket will hit the target. Try another. Try another.
Nice brain work. You solve this stuff like a pro.
Set the angle so the rocket will hit the target. Try another.
Oh, you are good! This time, the target has been placed right under the launch pad.
Set the angle so the rocket will hit the target. Try another angle. Try another. Try another. Here's a way I would solve this problem.
You know, you have excellent problem-solving abilities. Now you will need to set both the angle and the thrust for the rocket.
Set the angle and thrust so the rocket will hit the target.
Here's the station reference guide. It's great fun to browse through.
Earth spins like a top when it rotates on its tilted axis. It takes about 24 hours or 1 day for Earth to make one complete rotation.
Earth orbits around the Sun on a path that is almost a circle. It takes Earth 1 year, that's 12 months or about 365 days, to travel all the way around the Sun.
With enough thrust, your rocket can escape the Earth's gravitational pull.
When the Moon is 1/4 of the way around Earth, people on Earth see only half the Moon lit by the Sun. This is sometimes called the first quarter phase.
Traveling from Earth to Venus is a lot like traveling from a high Earth orbit to a low Earth orbit. But now you're moving from a higher orbit around the Sun to a lower orbit around the Sun. This trip may take a good number of stages. Do you think you're up to it? To go from a high orbit to a low orbit, the spaceship needs to slow down into a smaller ellipse. Then, at the right moment, slow down again to return to a circular orbit.
To go from a low orbit to a high orbit, the spaceship needs to speed up into a larger ellipse. Then, at the right moment, speed up again to return to a circular orbit. Ready to return to Earth? You can do it in 3 stages. First, fire the thrusters and head toward Earth. Then, get into orbit around Earth. Lastly, splash down.
To dock with a space station that's in a higher orbit than your ship, you will need to speed up at the right moment, changing your path, to intersect the station's orbit, right when the station gets there.
The full moon occurs when the Earth is between the Sun and the Moon. From Earth, we see almost all of the sunlit part of the Moon.
A hemisphere is 1/2 of the Earth. The half that's closest to the North Pole is the Northern Hemisphere. The half that is closest to the South Pole is the Southern Hemisphere.
It takes one final stage to land on the Moon. You need to slow your ship down, so that your ship will fall towards the surface of the Moon.
It often takes 2 stages, or burns, to launch this spaceship into orbit. First, you must travel up to where you want your orbit. But then, you must change your course to put your ship into a perpetual fall around the Earth. In other words, an orbit.
Time to leave the Moon's surface. First, fire your rockets on a path that puts you above the Moon. Then, change your angle and thrust to put your ship in perpetual fall around the Moon, a Moon orbit.
A lunar eclipse happens when Earth passes directly between the Sun and the Moon. From Earth, we see the Moon go dark briefly as Earth's shadow passes over it. If we were on the Moon during that time, we would see the Sun darken as Earth passed in front of it. The Moon's gravity pulls an object toward it, changing the path of the object and speeding it up.
It takes the Moon about 27 days to spin one time on its axis. Coincidentally, that's the same amount of time it takes the Moon to orbit once around Earth. So the same side of the Moon is always facing Earth.
A new moon occurs when the Moon is between the Earth and the Sun. The new moon appears close to the Sun in the daytime sky. With its dark side facing us, it is often difficult or impossible to see with just your eyes.
A spaceship or other object in a lower orbit will always travel faster than one in a higher orbit.
With enough thrust, your spaceship can travel far enough away to take advantage of Earth's curved surface. Gravity still pulls at the ship, but at the same time Earth's surface curves away, so the ship never hits the ground.
It takes 2 stages to get into orbit around the Moon from an orbit around Earth. First, set the thrust to get the ship out of the orbit it is in and headed toward the Moon. Then slow down to ease into orbit around the Moon. The path your rocket took is only part of an ellipse, or oval path, that goes all the way around the center of Earth.
Half of the Moon is always lit by the Sun. As the Moon orbits Earth, we often see only a portion of the lit half. It takes the Moon about 29 days, almost a month, to go through a full cycle of these different phases.
In June, the North Pole is tilted toward the Sun. As Earth spins on its axis each day, the region above the Arctic Circle stays fully lit by the Sun. People who live near this region do not see the Sun set for days or months at a time. This long period of sunlight is often called a polar day.
In December and January, the North Pole is tilted away from the Sun. As Earth spins on its axis each day, the region above the Arctic Circle remains in the dark. People living in this region do not see the Sun for months at a time. This is called a polar night. When the North Pole area has polar nights, the region below the Antarctic Circle has polar days.
If you launch your rocket at the same angle but with different thrusts, it will fall at different places.
If you launch your rocket at the same thrust but at these 6 angles, it falls at only 4 different places. Sometimes, a target can be hit using more than one angle.
To slow down the ship, fire your rockets in the opposite direction. This is called retrofiring and is the only way in space to put on the brakes. Sometimes you may need to turn your rocket around first.
A solar eclipse occurs when the Moon passes directly between the Sun and the Earth. If you could view the Earth from space during an eclipse, you would see the shadow of the Moon passing across the Earth's surface.
For 3 months, starting in March, it is spring in the northern hemisphere and fall in the southern hemisphere. For 3 months starting in September, it is fall in the northern hemisphere and spring in the southern hemisphere.
The Earth is tilted on its axis at an angle. Summer on Earth happens when one of the hemispheres of Earth is tilted towards the sun's direct rays. Winter comes when that hemisphere is tilted away from the sun.
The Tropic of Cancer and the Tropic of Capricorn are imaginary lines on the Earth. On June 21st, the first day of summer in the northern hemisphere, the sun's rays directly hit the Tropic of Cancer. On December 21st, the first day of summer in the southern hemisphere, the sun's rays directly strike the Tropic of Capricorn.
When the moon is 3/4 of the way around the Earth, people on Earth again see only half of the moon lit by the sun. This is sometimes called the third quarter phase.